Hi everyone, I'm Dr. Javier Cifuentes-Faura from Spain, and I'm going to make a presentation entitled Energy Technologies, Quality of Institutions and Sustainable Environmental Practices in African Countries. Thank you so much for inviting me to this conference. This work has been made with different researchers from other countries. The restoration of an enduring and ecologically balanced environment has emerged as an important goal in considering growing concerns about climate change and global environmental challenge. The ecosystems have been challenged due to unprecedented human activity, fast industrialization, and a growing population. The long-term variations in water and temperature brought on by human activity are referred to as climate change. The most frequent signs of climate change include an increase in the average global temperature and unpredictable weather. Recently, it has gained global significance as an urgent issue, impacting not just human well-being but also the sustainability of other species. The significant surge in greenhouse gas emissions in recent decades is mainly attributed to the combustion of coal and fossil fuels and deforestation. Therefore, the imperative of mitigating these environmental repercussions and fostering a healthy coexistence of human growth and nature has sparked a paradigm shift toward sustainability. The primary objective of Sustainable Development Goal 7 is to strengthen the energy system to move toward sustainability. Energy access plays a central role in the discourse of environmental sustainability, acting as both a catalyst and a challenge. More accessible renewable energy sources can reduce the environmental impact of energy production and use while boosting economic growth. However, lack of energy, especially in Africa, encourages biomass burning and other harmful practices. Thus, tackling energy poverty is essential to socioeconomic development and environmental sustainability, requiring a transition to renewable energy sources. The revolutionary growth in industrial development boosts countries' economic competitiveness but degrades the environment due to harmful energy use. At one point, the extreme utilization of energy-related resources surged the pressure on the natural habitats. In contrast, business attraction toward globalization and financial gains neglects the consequence of substantial resource depletion. Environmental deterioration is typically analyzed using macroeconomic, social, political, and sector-specific aspects in addition to economic development and energy consumption. Institutions have been vital in reducing carbon emissions and their economic and social impacts. Environmental sustainability programs depend on good governance and regulations. Strong institutions provide regulatory frameworks to enforce environmental laws, manage resources responsibly, and encourage sustainable activities. Transparent and responsible government promotes public engagement and collaboration, which are crucial to sustainability. Institutional quality goes beyond policies to ensure regulatory measures are executed and adapt to evolving ecological concerns to ensure long-term environmental sustainability. Institutions are crucial to lowering carbon emissions and the economic and social repercussions. So high-quality institutions encourage renewable energy through strengthened environmental regulations. This promotes green technology and knowledge, mitigating ecological damage. So the research on innovative strategies for a sustainable environment focus on Africa for multiple reasons. Firstly, Africa has an unparalleled ecological diversity, boasting unique ecosystems and a wealth of biodiversity crucial for global environmental balance. However, Africa also faces distinct ecological challenges, including deforestation, land degradation, and vulnerability to the impacts of climate change. Secondly, addressing energy access in Africa is paramount because a substantial portion of the population still lacks reliable and affordable energy sources. These energy shortfalls slow economic growth and encourage environmentally harmful behaviors, emphasizing the need for sustainable and inclusive energy solutions adapted to the continent's demands. Thirdly, adopting green technologies in Africa is crucial for steering the continent away from traditional polluting development pathways. Green technologies offer an opportunity to promote sustainable economic growth, minimize environmental impact, and leapfrog over environmental harmful practices. The data shown in the first figure illustrates the changing patterns of institutional quality, IQ, total green innovation, INV, and greenhouse emission, GHG, in specific African countries from 2001 to 2021. Fluctuations in IQ, IMV, and GHG levels reflect different levels of institutional quality, innovation, and environmental effects. Meanwhile, in the second figure, number V displays information on household power consumption, HPC, access to electricity, AE, and clean fuels and technologies for households, CFT, during the same period. Information on household power consumption shows an enhancement trend through these periods, indicating power availability has increased, reflecting energy infrastructure improvement. CFT, clean fuels and technology for households, advancements imply a shift toward greener energy. So the main objective of this study is to investigate the interplay among energy access, green technology adoption, and institutional quality to achieve environmental sustainability in 26 African countries from 2001 to 2021. So this work specifically addresses the following research question through three distinct but interrelated empirical models. How do access to electricity, EA, interaction of green innovation, institutional quality, climate change, expenditure, R&D expenditure, and GDP per capita individually contribute to the adoption of clean fuels and technologies for households in the African countries? How does the interaction between clean fuels and technologies for households and institutional quality, household power consumption, total green innovation, forest area, and growth collectively influence greenhouse gas emissions in Africa? And how do clean fuels and technologies for households, institutional quality, fossil fuel consumption, and renewable energy consumption contribute to carbon CO2 emissions in Africa? And finally, what policies may be drawn from this study to improve environmental sustainability in African countries? So this study extends current research by analyzing how household energy access, green technology adoption, and institutional factors affect ecological sustainability, greenhouse emissions, and CO2 mitigation, and clean fuel technology adoption in Africa. Secondly, integrating additional independent factors is essential to understanding Africa's complex sustainability dynamics, offering a unique and complete perspective. These factors, household power consumption, POP, AE, FA, the one that we have talked about this before, give us another perspective. Thirdly, interactive terms C, T, I, Q, and I, N, I, Q capture the combined influence of these variables, offering a more profound comprehension of sustainable development in Africa. Fourthly, the study used the most recent and complete data and robust results from well-equipped econometric techniques. And finally, the bootstrap Granger causality test will test the country-specific relationships in Africa. The empirical models employed to address the three objectives of the present study are delineated in equations number 1, 2, and 3. These equations are derived from the discussion in the introduction section concerning the significant attribute to each variable in the analysis of the environmental sustainability of the specific African nations. In the above equations, CFT represents the dependent variable, clean fuels and household technologies in the empirical model number 1. Greenhouse emission and CO2 also represent the dependent variables in empirical model number 2. And in the number 3, greenhouse and carbon dioxide emissions. These empirical models are used for regression analysis to estimate the coefficients and assess the significance and direction of the relationship between the independent and dependent variables. The choice of independent variables is based on their potential impact on the dependent variable. More importantly, they aim to achieve a sustainable development agenda for African countries. Electricity access is crucial for understanding the influence of clean fuel adoption and technology adoption, as greater access may promote the shift to cleaner energy sources. INIQ shows the interaction impact between total green innovation and institutional quality, underlining the need for innovation in a supportive institutional framework for clean technology adoption. The CC recognizes that climate change affects the uptake of clean technology, reflecting the study's sustainability aims. POP understands that population size may impact the demand and viability of sustainable energy solutions. R&D spending emphasizes the relevance of technology breakthroughs in adopting clean energy. A region's financial compatibility and economic development level are reflected in its GDP, affecting the affordability of clean technology. And in empirical model number 2, CTIQ captures the combined effect of adopting clean fuels and technologies and institutional quality on greenhouse gas emissions, highlighting institutional quality's role in environmental mitigation. The HHPC model examines how household power consumption affects greenhouse gas emissions and how energy consumption patterns affect the environment. The INV recognizes innovation's influence on greenhouse gas emissions and environmental sustainability. In contrast, FA addresses greenhouse gas emissions and ecosystems' role in reducing environmental consequences. In the empirical model number 3, CFT directly addresses the influence of clean energy uptake on carbon dioxide emissions, demonstrating how technical choices affect environmental results, and IQ indicates the institutional context and how institutional quality affects the ecological effect of institutional factors. The study employs a rigorous econometric approach to fulfill the research aims. The analysis began with the cross-sectional dependency test, which is necessary for panel data analysis because it can affect the prevalent shocks and the results. This study evaluated the presence of CST, cross-sectional dependency, in the data using the CD test developed by Pesaran. So the test statistics are followed, you can see on the screen. After confirming the CST's existence in panel data, the first generation stationary test is not reliable in the presence of CST. Therefore, to examine the presence of unit root, this study employed a second generation stationary test of cross-sectional augmented IPAs, CIPEs, and cross-sectional augmented Dickey-Fuller, CADF. You can see on the screen. This study has taken the initiative to investigate the effect of three main drivers in achieving environmental sustainability: energy access, green technology innovation, and institutional quality. So the study used advanced panel data, estimates on panel data from 26 African countries from 2001 and 2021, and the choice of research time framework was solely based on data availability for all the variables. So in the table number 1, you can see the information on the variables: clean fuels and technologies for house, greenhouse gas emissions, CO2. These are the dependent variables: independent total green innovation, institutional quality, climate change, household power consumption, affordability, gross domestic product per capita, population, access to electricity, R&D expenditure, forest area, renewable energy consumption, fossil fuel consumption, and the interactive variables: clean fuels and technology for house and institutional quality, and interaction and total green innovation with institutional quality. This table presents the statistical characteristics of the variables before the discussion and outcomes. The variable AE has the highest mean, while the variable IQ has the lowest mean. This suggests that although the study's participation nations have lower average IQs, they generally have relatively high electricity access levels. Furthermore, with a value of 83.37, IMV has the most significant standard deviation of any variable, suggesting more variation in the overall levels of green innovation among the nations. You can see here on the screen all the descriptive statistic outcomes. The next step was to use the CST test. The table shows that for each variable, the results affect the alternative hypothesis at a significance level of 1%. These findings demonstrate that due to their interconnectivity, CST is present in all the data from the African nations under study. The results of the CIPS and CADF unit root tests are shown in this table. The findings show that all variables become stationary at the first difference rather than at the level. We may deduce that there is a heterogeneous order of integration. The Westerlund's error correction model (ECM) values for panel co-integration are present in this table. The outcomes reject the null hypothesis of no co-integration and affirm the long-run association among variables for all three empirical models. This table shows the variables' coefficient values and connection using FGLS and PCSE. Empirical Model 1 shows that EA, CC, and RD have helped African states adopt CFT. In African nations, EA improves CFT because dependable electricity encourages households to use greener energy sources. Increased power accessibility could promote the use of green technologies, explaining the favorable connection. Climate change advocacy often encourages households to use cleaner energy and technology. These links demonstrate the interdependence between climate change strategies and improvements in household energy practices. The positive effect of RD on CFT shows that increased R&D investments promote greener energy sources. However, CFT is negatively correlated with population and GDP affordability. The findings are consistent with different studies. The negative relationship between population and CFT in Africa is due to the difficulties of scaling and offering inexpensive renewable energy solutions in more significant populations. Similarly, the increase in demand and associated constraints regarding resources may slow the implementation of cleaner technology. And finally, in this figure, we can see the bootstrap panel causality results for the relationship between IN, IQ, and CFT, along with CTIQ and greenhouse emissions. The findings are illustrated in this figure and demonstrate a two-way causal relationship between INIQ and CFT. There is a one-way causation from CFT to INIQ in all the studied countries. This demonstrates compelling evidence of a causal relationship between CFT and INIQ in African nations. This research emphasizes the significance of supporting sustainable practices in African households by leveraging institutional quality and technological improvements. And now we are going to summarize the main conclusions of this study and the policy implications. This study delves into the interaction of factors influencing environmental sustainability in African countries. The research examines the individuals and combined effects of energy access, institutional quality, population, R&D expenditure, and GDP per capita in adopting clean fuels and technologies for households and climate change. It provides insights into the complex factors influencing this adoption process. The outcomes reveal that energy access, research and development, and climate change positively influence the CFT in Africa. This suggests that environmental decision making in Africa is intricate and involves various factors. Moreover, the study revealed an inverse relationship between population and GDP per capita with CFT adoption, emphasizing the region's unique demographic and economic influences on clean energy acceptance. The investigation also demonstrated the mitigant impact of innovation and the interaction between clean fuels and technologies and institutional quality on greenhouse gas emissions, underscoring the pivotal roles of innovation and effective governance in environmental stewardship. Moreover, the current study finds strong evidence of causality between CFT, INIQ, and CTIQ, GHG in African countries. These findings highlight the complex interrelationship of sustainable practices, technical solutions, and institutional frameworks in influencing African environmental outcomes. So this research also provides practical guidance on how to improve environmental sustainability in Africa by implementing clean fuels and technology. It is recommended that policymakers prioritize enhancing energy accessibility and making significant investment in research and development to promote the development of innovative sustainable energy solutions. The inverse correlation among population, GDP per capita, and CFT adoption underscored the significance of customized intervention considering various African nations' distinct socioeconomic circumstances. The adoption of CFT can be significantly accelerated by initiatives to improve institutional quality and governance, highlighting the necessity of regulatory reforms and capacity building. Furthermore, the research emphasizes the potential sustainable energy sources and conservation initiatives, such as the preservation of forests, to mitigate environmental deterioration and foster long-term viability. So this is the end of this study on green energy technologies. Thank you so much for your attention. You can see my email on the screen, so don't hesitate to contact me if you have any question. Thank you.